All right, this topic is called definite integrals. And as a reminder, a definite integral has a solution that is a number. It's basically the area under the curve from your lower bound to your upper bound. So as a reminder here, the uppercase F, if we were to take a derivative of it, we get this. Okay, and so we basically find the integral like we do with indefinite integrals, but then we put in our upper bound into our function that we get, and then we put our lower bound and we subtract those two values. So let's do one. So what is the integral from 0 to 1? That's how you read that. You start at your lower bound. So the integral from 0 to 1 of x cubed plus 3. And just as a reminder, that dx, it means something fancy, but we're just going to think of it as the variable of integration. So this problem is actually asking, if we look at this graph, what the area under the curve is from 0 to 1. And to do this, we're basically going to integrate, and then we're going to substitute into that function for both the upper and lower bounds. So to integrate my x cubed, remember my rule is to go x to the fourth, we're adding 1 to this, and then we divide by 4. Now the integral of plus 3 is going to be a plus 3x. Now remember how we wrote plus k or plus c? You can certainly do that here, but the thing is, when we plug in, we're going to get a plus c and then a minus c. So for definite integrals, you actually don't have to write the plus c. What we do like to do is do this large bar, and I put my 0 and my 1. This essentially says that my definite integral is equal to this, and what I'm going to do next is plug in my 1 into both of the x's, and then I'm going to plug in my 0 into both of the x's and subtract those two answers. So plugging in 1 first, I get 1 to the fourth, which is 1, divided by 4 plus 3. Then minus, and you need to remember your parentheses. Now I'm going to plug in 0. Well, that's going to give me 0 to the fourth, which is 0, divided by 4, which is 0. Okay, and then plus 3 times 0, which is again 0. So our actual answer is just going to be 1/4 plus 3 minus 0, or we can think about that as 3 1/4. All right, there we go. We've done our first definite integral. I know what you're saying. You're looking at this integral and you're saying, oh my goodness, trig. But I have put two graphs on the screen for you. One is, of course, sine x, and this one here is cosine x. So we can refer to that, but you should have those memorized. All right, first step for a definite integral is to flat out just take the integral. And so this is going to be a sine x. And yes, it is sine x plus c, but remember, if we were to plug in both situations, we basically would have gotten a plus c here, and we would have had a plus c here. But with that distributive property, it would have made it a minus c. So we'd have a plus c and then a minus c, and it would cancel out. So we don't need to do that. All right, so let's just check this. Is the derivative of sine cosine? Yes, it is. So I've done this right. And now I'm going to evaluate that from 0 to 3 pi over 2. And as a reminder, we put in the upper bound first. Okay, see how we put in the b upper bound in first. So I'm going to get an answer of sine of 3 pi over 2 minus sine of 0. So a sine of 3 pi over 2, well, we go up here, a sine of 3 pi over 2 gives us -1, minus, and you might want to remember your parentheses, especially if we get a negative here, sine of 0 is 0. So we get -1 minus 0, which is equal to -1. Now let's see, does this answer make sense? You know, we got a negative answer for our integral, and we're really talking about the area from here to here. And absolutely, you can see that there's more area that exists under the x-axis, meaning that our overall area should be negative, and that is true in our answer. So that is good news. All right, I'm going to leave this for maybe class time, but go ahead and try that homework and we'll have plenty of practice problems in class. All right, bye-bye.